that you got a fail. Okay, there's a fail result in here. Yeah. So what can we do? Change it? No, you need to wait. You need to think about the analysis about the data. As I told you, there's a floating with no connection, which means I don't need to care about that. But what kind of information caused this fail? It means it's low, and the low status in here. In the logical trace, you can see the pattern is wrong in here. Okay, and also you can notify this output is not very high. So that's something suspicious in here. But you can go to the IC's page, you can see more detail in here. You can see the pin 6 connected to the pin 8. Okay, as output and output. It's unusual, is it? And you can go to see here. This one is the 333 input, then get open collector. So it could be this kind of circuit in here. I'll show you about this. Okay, this. It could be this one. Okay, because the output connect together, because it has open circuit, so I have to put up the resistance in here and connect to the 5 volt, which is VCC, and 3 input in here. But why our result is a fail? Because we test it separately, and if they have something, some other gate, and to change the output and change our measurement, and we will get the wrong stage. But however, in this kind of scenario, we can do more with our graphical text generator. Okay, but however, we can save the data in the end. Save the data and copy the state, and we can change to the graphical text generator. Yeah. So we can type in the same part number in here. So we don't need to care about the get one because that is totally no use. Okay, so we just change the state 2 to the output, mean the drive signal from system to the input of the pins. Okay, so I just drive it and drive it. Okay, once you finish the setting, you can set up the data. So you just need to do the one time. And we don't need to go to the 10 step, we just need to 5 because we just need to try high and low, all of that. So because that's an NAND gate, we just need to test this point is working or not working. So we just make sure the setting is correct. Okay, that's correct. Okay, turn on the power. Okay, and we just use mouse to program to change the status that we want to output. Okay, so I just given the A, B, C, all of the input be high, so it should be low. So I just learn. Yeah, we got low in here. How about I change the status? How about I change this one? Turn off, not turn off. Sorry, go to the low state. Okay, it should be, yeah, it's still on because that's white OR gate in here. It's an OR. Okay, so if I turn off another side and turn on this side, and what we got? I will get the same result in here because that 2Y the same as a 3Y. If I turn off all of that, only one. And then, yeah, disappear. Okay, so what do you think? Is it okay or not? It's okay. Okay, it's okay. So in this, for the BoardMaster, okay, if we want to test the result like this one, you want to send me the result, okay, 7412. Yeah, 741. Okay, save. Okay. If you want to test it again, you can go back to the previous state to test it again. Okay. And if we want to do more, you can use the graphical test generator to set up the testing pattern, as I just showed you. And also you can save the data, all of the data in the test board, as I mentioned to you a lot of times. And the one thing you need to understand is we have off the drive. It's not only you can change the status in the pattern, but also you can change the voltage from the 10 to the -10. Okay, so if you just press OK, accept and run and learn, they will generate high will be the 10 volt, low will be the minus. It's allow you to testing the more application, more device, like communication device, 7-5 serial device for differential communicate IC. It allow you to test that by using the graphical test generator in the ATN, in the BoardMaster.